Hey, my name is Tyler Slaton. Today I'm going to be your guide in helping you to build a generative AI application. More specifically, we're going to be building a generative storybook. This will allow users to enter a prompt as well as the page count to be able to actually generate a children's story that they can then view in the application. We're going to be leveraging technologies like GPTScript for the generative AI portion. And then for everything else, we're going to be using Nuxt, which is a full stack framework. With that, let's go ahead and get started. All right, so this is GPTScript. It's an open source project that we've been working on for over the last couple of weeks, going on a couple of months now. The sales pitch for GPTScript is that it's a natural language programming language. Okay, so what this means is that you can prompt LLMs to do various concepts that we would traditionally do in programming. Think of things like functions, loops, if statements, that sort of thing. So GPTScript does this through a concept called tools. So everything in GPTScript is a tool. You can have multiple tools in a script, and you can even import tools from other files that are remote or local. So in this example here, we give the script some system tools. These are built-in tools in the language that require no remote references, which you can see right here. And we do this in what's referred to as the root tool. So you can actually define multiple tools in a file. And the first tool is usually what's referred to as the root, as this is what's imported by other applications that are going to be using your script. It's also what's run by default when you actually execute a GPT script. Okay, so in this script, we tell it to download the file here. This is actually a SQLite database. We tell it to expand that archive, and then we tell it to inspect that database to understand the table structure. And then finally, we ask it to form and run a SQL query against that database and ask it to get the artist in that database that has the largest number of albums. So once we call this, it's actually going to go ahead and do that. And we can see that Iron Maiden is the one that comes out from that. So that's kind of a complex example to start with. So let's look at something kind of simpler. We have a lot of examples in the GPTScript repo, so let's just pick one. I like the echo.gpt, so let's take a look at that. It's really, really simple. We have a description. This tells any importing AIs how to use this particular tool. Then we have an arg here. An arg is essentially exactly what you think it is. It's something that we provide to this tool that it's then going to use inside of it. We give it a name, which is input, and we give it a description, which in this case is just any string because we're going to be importing that. What's kind of cool about this is this actually gets sent to the script as an environment variable. So the environment will have all of these values as well. Then when we actually execute this, this is the prompt that gets actually run. In this case, we just ask the AI to go ahead and echo the value of that input. Okay, so that's a little bit on the simpler side of things that we've looked at. Let's look at one final example called the recipe generator. So what the recipe generator does is it takes an image and it looks for ingredients in that image, and then finally it spits out a recommended recipe that you could actually make with that. Okay, so we see some new things here. We import these tools. In this case, we have some system tools just like last time. We have a second tool that's actually written in here outside of our root tool, which is called the recipe generator. And then finally, we have a remote tool, which is hosted in GitHub. GitHub tools are actually pretty cool because we actually have a full site that allows you to interact with these. You can see all of the system tools like this. You can also see all of the tools that are in the database. So that's kind of cool. We also have a documentation site if you want to go ahead and take a look at that as well. A lot of this we already kind of covered over, but if you want something written, as well as like maybe you want to use an alternative model and things like that, we have documentation for all of that. This is an example of a remote tool. We're going to be using the Vision one for this recipe generator one that we're looking at right now. So this is the Vision tool. In particular, a remote tool just needs a tool.gpt. And this tells it how to actually use that tool. Cool, so we have a tool that's able to visualize something. We have a recipe generator tool, which generates a recipe, and then we give it some steps to perform. So that's actually what we're going to be doing today in a pretty simplified format. We're going to be using the image generation tool, which is what we were looking at before here. And we're going to be creating three tools the root tool, we're going to be creating a story writer, and then we're also going to be creating a story illustrator. Story writer will write the story, illustrator will illustrate the story, and then the root tool will be able to actually go and delegate tasks to each of those. So now that we have a rough idea of how we're going to be utilizing GPTScript for the generative AI portion of this, let's go ahead and take a look at Nuxt, which is going to be the full stack framework that we're going to be utilizing over the course of this video. And let's get started. All right, so we're going to be wrapping the generative AI portion of all of this in a full stack framework called Nuxt. So what is Nuxt? Nuxt is essentially your UI and your backend in the same framework. Specifically, your UI will be in Vue and the backend will be using Node. The backend portion of this uses this concept called file-based routing, which is a pretty interesting way to build out APIs. And as we get through a lot of the tutorial pieces of this, we're going to actually understand that a lot better. You can actually swap out Nuxt for any sort of backend, front-end combination that you want. We just really like Nuxt here at Acorn Labs, so that's what we're going to be using today. Finally, since I'm not a web designer, I'm actually going to be using Nuxt UI, which is a component library that Nuxt developers have gone ahead and written for us. So with that in mind, we're ready to start actually writing some code. So let's get to it. All right, and so it begins. I've got a fresh and empty repository ready to go in VS Code. I've gone ahead and named this storybook example, but you can name it whatever you want. You'll want to make sure that you have at least the same version of Node as me. So to make sure things act similarly, make sure you're around v20.11. It's okay if you're a little bit lower, a little bit higher, but try to aim for around there. We're going to be using a tool called Nuxie that the Nuxt developers have written for us that'll actually generate a lot of the code that we're going to be starting with in this application. So let's go ahead and use that now using the npm npx tool. We're going to be prompted for this, like which package manager we're going to use. The rest of this is going to be an installation process. The dot at the end of this command here just says go ahead and use this current repository that we're in. And now we're treated to this installation process. You can select whatever you want for these options, but for our purposes, we're just going to be using npm. So select that if you want to remain consistent with me at least. Next up, it's going to start installing our dependencies. So we'll go ahead and let that run for a little bit. And when you get to this step where it asks you if you want to initialize the Git repository, go ahead and select yes, because I like to have the Git associated with all of this. And then we're done. Cool. So now we have a boilerplate application with all of the beginning code that we need. With that out of the way, let's go ahead and start installing the packages that we'll be using in this tutorial. So kind of one at a time, I'll start showing you which ones we're going to be using. We're going to be using the Node module that GPTScript, us at Acorn Labs, have written for you to execute GPT scripts. Then we're going to be utilizing the Nuxt UI framework that I mentioned earlier. We're going to be using Sharp, which is a framework for image compression. And then we're going to be using Pinia for a store, which we'll get to when we're ready. You don't need to know too much about that for now. So let's go ahead and install those. And it seems that I mistyped Sharp, so let's just go ahead and do that. And I also mistyped Pinia, so give me one moment. Okay, so now we're installing those, and shouldn't take too long. Let's go ahead and finish those up. All right, so now we have all of our dependencies installed. Finally, let's go ahead and adjust our Nuxt config to import all of the modules that we'll be using during this tutorial. We have a little Nuxt config that was generated here. We're going to be importing our modules like so. Modules are basically pluggable code from into the Nuxt framework from other developers. In our particular case, we're using the Nuxt UI plugin, the Tailwind CSS plugin, and the Pinia Nuxt plugin. This is kind of similar to like packages and other frameworks and things like that. So this is a pretty nice way of just injecting code from external developers into your application. Now we can go ahead and run our application locally with the dev command that Nuxie wrote for us. So that's actually going to be npm run dev. This is going to open up the application on localhost 3000 for your browser. Go ahead and take a look at that. For now, it's just going to be a simple boilerplate kind of tutorial that Nux has written off for us. But notice there, we're going to be touching this a lot more as we get through the rest of the application. And we'll be editing it over time as well. So a good starting point for us to actually build out our application is going to be building the GPTScript that will be actually generating everything. Once we have this finalized, we'll build our API that will serve as a way of executing that script on demand. And then finally, we'll build out a UI that allows users to generate their own stories. So like I mentioned, let's go ahead and start with the actual writing of our GPTScript. So to do this, we could just go ahead and create the storybook.gpt file, which all scripts in GPTScript is actually a GPT file. So we're going to be iteratively building out the actual script that we'll end up with. I like to start with all of my scripts defining what args I'm going to be using as I go through this. So let's go ahead and do that. These are the args that we're going to be using. They're pretty self-explanatory, but just so we talk about them. Story is the prompt that we will provide the user. It is allowed to be either a prompt or an actual story that will be illustrated. Pages is the number of pages that was requested for generation. And finally, path is where all of the generated content will be written to. So next, we'll define the other tools that we'll need. When we're writing GPT scripts, I found that it's actually really useful to break up your tasks into separate experts, if you will. They're each able to do their respective tasks very well. This allows each tool not to get overwhelmed as we do more complicated tasks and as the context for each of those tasks increases. So the other two tools that we're going to be writing here, as I mentioned earlier, is going to be the story writer and the story illustrator. So when you're writing a tool, you can actually separate it using these dashes here, and that defines a new tool. So let's go ahead and start with the story writer. So first off, we're going to go ahead and define our name, as well as each of the args that we're going to be using. The prompt is the prompt that we're going to use for the story, and the pages is the number of pages that that story should have. Next, let's go ahead and write a description for the tool. This tells any other tool that's utilizing it what it does. So let's go ahead and get that in there. So in this case, we're a tool that writes a writes a children's story, returns a story, illustration style, list of settings, and a list of characters with their physical descriptions. We'll get into what all of that means here in a second as we finish this up. But finally, we're going to set the temperature. The temperature is right there. And basically the temperature tells the LLM how random and creative it is allowed to be. For this task, we want it to be especially creative, so we set it to 1. The range is between 0 and 1. You don't want it to always be as high as 1, as it may lead to the LLM ignoring the context that it's been given. And GPTScript by default actually sets this to 0. So next up, let's actually write our prompt for this tool to utilize. So let's get that into there. Cool. And so this is our prompts. Sorry for the formatting errors. I'm just going to fix that up real quickly. And yeah, so this is our prompt. You can see there's a couple of things here, and I want to tackle it one sentence at a time. So you are an accomplished story writer. It's been somewhat proven, and in my experience as well, that if you tell the AI that it's good at something, it actually does better. So in this case, I just tell it it's an accomplished children's story writer. Then I tell it what it likes to do. You like to write in a style that is appropriate for children, but is still interesting to read. I said interesting to read because some of the stories that it would write were somewhat, more oriented towards 4-year-olds as opposed to 9-year-olds. And so by adding this prompt, it actually generates some more interesting stories to physically read. So with the style that we've defined up here, write a story based on the prompt that has the specified number of pages. Along with the story, write an extensive description of each character's physical appearance. Be sure to include things like hair color, skin tone, hairstyle, species, and any other significant characteristics. Write an extensive description of what settings in the story look like as well. Finally, determine what style that illustrations of the story should be written in using 5 words or less. If the prompt provides one, use that. Return your story, illustration style, and character descriptions. So that was a lot, but essentially what we're doing here is we're telling the AI to generate the story, tell us what each of the characters in that story look like, and tell us what the settings in that story looks like. This is important because as we go to the story illustrator, we're going to actually pass all of these values off to it so that it knows what things look like as it's generating characters. So instead of having disparate random images for each character between pages, the characters start to look more consistent as we apply this specific prompting style. Okay, so with that, we can actually go ahead and write our story illustrator. So following the same process from before, let's go ahead and get our args as well as whatever tools we're going to be using in here. Also for the story writer, we're going to be importing that as a tool up here. We'll get to that in a second. But for the story illustrator, we're going to be importing the image generation tool. So let's go ahead and do that. As mentioned earlier, these are all hosted in GitHub, and so you can reference them as such, and actually clicking on this link will actually take you directly there. Let's go ahead and get our description in there. Just generates an illustration for a children's story. All right. Its temperature is also going to be 1 because we want it to be creative as it does this task. We will have the text of the page that we're going to illustrate. And we're going to also have the characters that I mentioned earlier, as well as the settings that I mentioned earlier. It gives us a physical description of what each of those things look like. Then one last thing is the style that the image should be generated in. This is actually passed along as well from up here, which is that illustration style. One thing that's kind of missing here is the setting descriptions, but the AI is actually smart enough to know that we want to return the setting descriptions as well. But let's go ahead and add that just for clarity. Do that like so. Cool. Awesome. Back to our story illustrator. Let's go ahead and get our prompt into there. So let's grab that. One moment while I grab that. Okay, cool. So, sorry again for the formatting issues. So let's go ahead and fix this up. Awesome. So let's read through this again, one sentence at a time, just so we understand what we're doing. So we tell the AI to think of a visually interesting prompt to generate an image to represent the text of this page. If a character is not present in the prompt, do not include them. If a setting is not included in the prompt, do not include it. Do not include the name of any characters or settings in your prompt. Just use their physical appearance, just their physical descriptions in characters or settings, instead to ensure that they look like they should. Check if your prompt is safe for children. If it is not, make a new one. And finally, use your prompt to generate an illustration. Append any prompt that you have with dot in a style children's children's book style. Do not include text ever, because sometimes it'll include text, which is, if you have not seen AI generated text and images, it is not great. And then only return the URL of the illustration. If your image fails to download, try again with the same prompt. And if your image fails to generate due to community guidelines, generate a new prompt and try again. You're only allowed to try again 2 times maximum. So there's this very explicit style that we're going through as we're building out these prompts so that the AI understands what we're actually trying to do here. What this will actually do is it's going to pass back whatever calls this, the illustration of the URL to the illustration that has been generated. And the AI will actually come up with these really interesting prompts based off the text, character settings, and the style to visually generate something that we want it to look like. One last thing is I want to go ahead and write this out because we're going to need it. But we're going to make this makedir tool, which is going to just allow the LLM to make directories. This is not something that's built in to GPTScript. It's not a system tool or anything like that. So we just go ahead and make that, and we're going to tell the AI to do is to write to this directory, and that's that. Cool. And so now we're actually able to build out our root tool. So let's go ahead and do that. We haven't imported any tools yet, so let's go ahead and do that, which we can see right here. We're going to be using the story writer that we wrote, the story illustrator, the makedir, system.write to write files, system.read to read files, system.download to download them, and system.abort to end the process if anything happens that we want to abort from. Next, let's go ahead and add the description. Just pretty simple, writes a children's book and generates an illustration for it. Generates illustrations for it even. Next, let's add up our arguments. So story, again, this can be a complete story or just a prompt for one, as we've actually mentioned up there. So we actually don't need to do that. We've already done that. We have all of our args. We have our description. Now we're going to actually write the script that we need. So let's add that in now. Cool. Let's fix up all of the formatting errors. And then let's tackle this one at a time. Pretty simple, but let's just figure it out. Okay, so do the following steps one after the other without skipping any or ending early. This is actually no longer needed as it's built into GPTScript's system prompt. So if you wanted to do one of these, like do these steps in order, it will not skip them. Awesome, so next up. If the story is inappropriate for children, abort the process and cite the reason why. This actually knows to call the sys.abort tool when it's doing this, so that's pretty cool. Next up, it's going to come up with an appropriate title for the story based on the prompt. Then we're going to create a directory at path/story title, and if it does not already exist, and we're going to replace any spaces in the title with a dash. Sometimes the AI will generate a weird directory where the spaces are there. So we don't want that because it kind of adds some complexity into the application that we don't want. If the story is a prompt and not a complete children's story, i.e. if they pass it a past and complete children's story, then call the story writer to write a story based on the prompt. If the generated story is not appropriate for children, abort the process, similar to up here. This step, I didn't mention, is actually able to understand to go ahead and execute the story writer. And then finally, for every page that we got from the story writer, we're going to call the story illustrator and illustrate it, write the content to a page, and download the illustration file. So that's actually our entire script, believe it or not. This will do all of the generation that we need, and we don't have to do a whole lot more outside of that. So next up is just going to be building out the API and the UI to physically execute this. If you want to run this locally, you're going to need a open API key. You can actually see this in our docs, but for the sake of the security, I've written this to a env file, so I don't have to on camera show you what that is. Then I can just do GPTScript, and I can call this script, which is the storybook, story-book.gpt. I'm going to give it a story, which I'm just going to say is foo. I'm going to give it a pages of 1, and the path I'm going to set to be stories, like that. And I need the dash as well. Cool. And so I'm going to go ahead and execute this. We'll start to see some stuff go through, and we'll come back once it's finished. But we can kind of see it generate in real time as well. So once this is finished up, we'll take a look at what its output, and then we'll start to build out our API as well as the UI. We can see that it created the stories directory and actually created the directory for the title, The Adventure of Foo. I'm just going to end it here, let it finish up, and then I'll come back with another video as well. All right, so the story has gone ahead and finished up. Off screen, I actually added stories into the getignore so that it doesn't show up as a new file. This is our lovely little creature named Foo, and this is the story that it generated. So this is the file format that we're going to be working with throughout this tutorial. Looks like it worked pretty well, and I'm pretty excited to start building out some API routes around it with you. Awesome. So with that being said, let's go ahead and get started. As I mentioned earlier, Nuxt utilizes this concept of file-based routing. So as we're serving pages and as we're building out the API, we're going to be creating files that build out our routes. So with that being said, we're going to create a file in the server directory, and in that we're going to provide it the API and stories subdirectories. Cool. And so with that, now we have a server/API/stories directory. What this essentially says is that we now have a route for our application on /API/stories. And anything under that stories directory that we define will be a route for that. So a good starting place is that we're actually going to be able to, we're going to set up something to retrieve a story from a specified directory, specifically this stories directory. As we're building this out, we're going to need a new environment variable that we have actually yet to set up. We can do that in the Nux config using this concept of a runtime config. So let's go ahead and add that. So first we'll define our runtime config like so. And then we're going to be using this value of Nuxt stories volume path. So let's get that in here like so. And then we'll close this up as well. All right, so runtime config is going to create these environment variables for us that are able to be set like so. So in this case, it's going to add Nux at the beginning, capitalize everything, and between each letter that is capitalized, starting from the beginning, it's going to add an underscore for us. And this is how we actually set it. So if we wanted to change this when we go into a production setting, that is how we would do that. Okay, so now let's go ahead and build out our route that allows us to actually grab and retrieve all of the stories that are available. We're going to first do this by creating a new file called index.get.ts in stories. This will create a get route at the index of stories. More specifically, we can now call get on /API/stories, and that will retrieve all of the stories for us once we fill this out. So let's go ahead and do that. We're just going to bring in some code. I'll take this one line at a time for us so we can understand what we're doing. First, we're going to import the file system module for Node, because as we're writing in the server, this is actually going to be in Node that we're writing this as opposed to front-end JavaScript. Awesome. And next up, we'll do that. We're defining an event handler for Nuxt. So let's go ahead and do this. All right. And we have that in there now. And so next up, we're going to add in the call to actually try and retrieve some stories out of the file system, which you can see here. Things are actually red right now as I'm in a weird state. So let me fix that up really quickly. All right, so we are fixed now. All of the red should be gone. And then we're good there. Cool. So next up, just to recap where we're at, we create the stories by retrieving them from the stories volume path. In our particular case, we've set this to actually be the stories directory here. So it's going to grab all of the files from inside of there. Next, we'll return that value like so, where actually, so the library is specified in the base application. We're not going to be setting that today. So we can actually just do the following. We can just return await fs.promise. A promise, if you're not familiar, JavaScript is a way of doing some asynchronous threading type of things. Finally, we're having this try catch block just in case something fails and like there's no stories to be found as an example. So let's go ahead and add a catch statement here, like so. Alrighty, so we have that now. As we can see, if we get any error code that's similar to eno_int, then we're just going to say that there are no stories found. Otherwise, we'll return a 500. And so once we call this route, we're actually going to get all of the stories in this directory served to us, specifically their titles. So in this case, it'll return the adventure of Foo in this route. Next, let's add the ability to actually get the specific details of a story, like the page content and any images associated with it. So to do this, we're going to create a route with a route parameter. In this case, it's actually called name. So I had to fix up the getIgnore to be a /stories instead, because otherwise this was getting ignored. And then the other thing I wanted to do is go ahead and create that route parameter route I was mentioning earlier, where it's name.get.ts, like so. This is going to allow us to actually use a route parameter, which we'll see as we start to write this code. So let's go ahead and get some stuff going here. So we're going to import fs from fs and import path from path. These are all node modules. We're also going to import something that we're about to implement, which is this pages type right here. So let's go ahead and implement that. We're going to create a new directory called lib. And inside of here, we're going to create something called types.ts. And in there, we're going to add some of the types that we'll be using as we're writing out this application. First up on our list of types is going to be pages and page. A page just has an image path as well as the content, and pages is a record of that, which is something like a map if you're familiar with Go. Awesome, so we have that set up now. Let's go back into here and start doing some more of our code. We're going to define another event handler like such, close that off. Then we're going to do that try catch, same pattern as before. This time we're going to get the route parameter with the get route param function that's provided to us by Nuxt. Then we're going to decode it. Sometimes the URL, the actual name of the story, will have a component inside of it that needs to be URI encoded. So we'll go ahead and decode that. Then next up, we're going to get the story's volume path out of the runtime config. Then we're going to use the file system module to go ahead and read all of the files in that directory like such. And we're using path.join to join the volume name of the volume path as well as the name of the story we're trying to read. Then we're going to build out a pages variable that we're going to be using. And finally, for each of the files that we found, if the file does not end with a txt, i.e. it's an image, we're going to continue. Otherwise, we're going to read the file in UTF-8 format, and that's going to be the page content. And then we are going to do the following. It's not copying over, 1 second. All right, and so then we're going to do the following. Inside of files, inside of the pages struct that we're making up here, we're going to replace the txt out of the page that we're currently on and replace any page part of it with just nothing. And then it's going to associate that with page 1 inside of our structure. And then we're going to give it the image path, which is in a route that we've yet to implement. We'll implement that next. And then finally, the content will be the page content that we got from up here. Lastly, we can go ahead and return that. So let's go ahead and add that right here. Return pages. All right. And to finish this off, we'll do some error catching like such. We will return do this, do that, and then return pages like so. Awesome. Cool. So in this case, we are a little bit off in terms of spacing, so we'll just go ahead and fix that now. Cool. So if there was an int in any case, then we're going to return the 404 just like the other place, and otherwise we're going to throw a 500 for any errors that occur. Cool. And so now we're able to actually get stories in a format that looks like this, where we will have a string record where that'll be the page number, so specifically 1, 2, 3, etc. And then the page itself will have the image content, the image as well as the content of that page. All right, solid. So last up, I mentioned that we have this image API that we have yet to implement here. So let's go ahead and implement that. We're going to create a new folder called images inside of the API. And in there, we're going to create an index route for a get. And then we're going to use sharp, if you remember when we installed that from earlier, to compress that image for us so that we don't have a huge image that we're returning from the server itself. Cool, so let's go ahead and start importing stuff. This exists sync allows us to say if that image exists or not. Sharp is the Sharp module that I mentioned earlier, and path is built into Node to allow us to safely build paths. All right, so we'll go ahead and start to write this up and finish it up. So we're going to build out our image path like so. All right, and here we get our story volume path, and we join it with the path of the image that was specified in the router parameter. The name of the image actually needs to be the following. That ... specifies that it will actually have all routes that are sub routes of images. So images / the adventures of Foo / page1.png as an example, and it'll actually store that under path. So we create another router parameter out of the path here. Next up, we are going to check to see if it exists and return an error if it doesn't, which is right here. And lastly, we're going to use the underlying node module of our event here to set the header type to JPEG. We're going to compress the image into a JPEG and then buffer it. And then finally, we're going to tell Node that we want to go ahead and return that, like so. Specifically, return that compressed image that we've created. With that, we're actually able to call our API and get images and the content of stories. So next up, we're going to go ahead and start to create the ability to post a story and stream its progress to the UI. So as you may have noticed from when we ran our script, it takes a really long time for that to finish executing. This is for a variety of reasons. For example, we're generating images and text and writing to files and downloading and things like that. So this is a pretty complex task that will take a bit of time. We can alleviate this by actually improving how we stream updates to the UI so the user knows that it's still running and what is actually happening. So we can do this in a couple of ways, but I opted to utilize this thing called server sent events, or SSE for short. This is essentially a socketless form of streaming updates from a backend to a front end. The only caveat is that it is a one-way connection from the backend. In other words, we can't send any data from the front end to the back end in the stream, whereas with sockets, you're actually able to do that. Anyway, here's what we have going and what we're going to be implementing. I wrote this in Excalidraw, by the way. Great program. Check it out if you want to give it a look to draw hand-drawn diagrams. So you'll see the Nuxt UI on the left and the Nuxt API on the right. This little box here indicates that this whole process is us subscribing to and receiving server sent events. First, the UI will subscribe to the stream via get call to the API/story/SSE endpoint. This will allow the UI to receive updates from the API. As the script progresses, events will be written to the stream. And as there can be multiple stories that are generated, an ID will be attached to each pending event so that we know which story needs to have that event as well. Finally, the UI can unsubscribe from this so that we don't have any lingering streams as well. Now, let's go ahead and implement the post route where we'll actually start a story generation, and then we'll end by implementing this get route where the UI can subscribe to it. Finally, we'll take a look at what this looks like in Postman before going and moving on into the UI. To create the post route, we're going to create a new file called index.post.ts inside of the stories directory. So let's go ahead and do that. Next up, we can start actually implementing all of the code in here. So first up, we're going to add the GPTScript module that we installed earlier. We're going to use this to actually execute our GPTScript. Then we're going to import readable from stream. We're going to be creating a stream that is going to be stored in memory, and we're going to need it for that. And then finally, we have some types that we're going to be using. We have yet to implement either of these, so let's go ahead and create those now. Back in our types.ts, we'll add in the types. First up is the stream event, like so. The stream event has an ID, which we will associate a pending story to, a message that we want to communicate, if this is the final message or not, and an error if any errors occurred. Next, we're going to create a story request. This is just going to store the body of our request that we'll be receiving from the UI. It has a prompt and the number of pages as well. Cool, so we'll save that, come back here, and this is all good to go now. So next, we're actually going to define our in-memory stores. So we'll define our running scripts. This will just have a ID to the prompt. This will allow us to know what prompt was associated with what ID on the UI side of things. Then we're going to export an event stream. This is just going to be a readable that is able to be read from. By the way, we're going to be doing both of these in memory. So if the server restarts, for example, both of these will be depopulated. If you want to actually store these in a better way, you could look for something like Redis to store your promises. However, for the sake of demonstration, we're not going to be getting too far into that. So running scripts will house an ID, as I mentioned, that will have a mapping to prompt. And the event stream will be what our SSE route will actually be hooking into. Awesome, so let's go ahead and get started. First up, we're going to define our event handler. And then in here, we're going to be reading the body of the incoming request, and we'll make sure that the required values are passed. After that, we're going to go ahead and actually execute our prompt. So let's grab that code here and paste. What you'll see here is we're grabbing our stories volume path environment variable that we set from earlier. Then we're grabbing standard out, error, and promise from execing the file. This is a stream exec file, but you can actually do a lot of stuff with this module. For example, you can just pass the raw storybook.gpt to this, but here we have the file, so we'll just execute the file. Next up, we're going to need to create the ID of the pending story. So we'll just do something quite simple. We'll just generate a random ID for this, like so. And then we'll add it into our running scripts with the request.prompt. Next up, we're going to set up some event listeners for this. So here they are. First, on standard out, as new events come through, we want to push that data that's from those events to the event stream. And if anything comes through to standard out, then the script has actually finished, so we set final to true here. And we stringify it into the event itself. This is actually really specific to SSE. You need this data prepending here that tells you what kind of thing this is, and then \n to denote that it's a new event that's coming through. Finally, we're going to go ahead and handle the promise so that when it finishes or errors, we're handling it appropriately. So in this case, we catch the error. We create a new event with the message that says that the error is occurring. And we finally delete it from the running scripts because this is now finished. So we'll go ahead and save that. Finally, we're going to set a response status that we have received this and are processing it, which is what 202 means. Now we have two more routes to implement, and they're quite simple. So we've actually done the brunt of our logic here. First, we're going to create a way to grab pending stories. So we'll just do pending.get.ts like this. So this is actually a really simple route. We're going to be grabbing the running script store from the post up here, and we're just going to return it raw so that we know what pending IDs there are currently, as well as what their prompts are. Finally, we can set up the SSE route that the front end will connect to in order to receive updates. So let's go ahead and create that. We're going to create sse.get.ts like so. And this is also relatively simple. So let's go ahead and bring that in and talk it through. Awesome. Cool, so let's talk this through. So first, we set the response status to 200, acknowledging that this is a success. Then we set the event headers, and this is actually what's super important. The connection, keep alive, and the content type. This actually tells the UI that this is an event stream. Finally, we tell the event that we're going to handle it ourselves. And then finally, we start streaming events from the stream itself. We're going to read the stream, and on data being received, we're going to write it to the stream so that the UI will be able to receive this. With that, our API is actually complete. So now we can start on the front end, but first we're going to take a look at what this looks like in Postman. All right, so we have Postman right here. Postman, if you don't know, is a way to send API requests in a pretty nice way. It has quite a great UX, so give it a look if you like it. But first up, we're going to be submitting a post request with the body that we mentioned earlier, where we have a prompt as well as a number of pages. In this case, just 3 friends on their way to Mars, and we want it to be set to 2 pages. So we'll go ahead and send this. Well, first up, we need to start it, so let's do that. We can just do yarn dev, spin that up now. Give this a moment. And cool. So we got a 202. Now let's go look to see the pending jobs. We can see the ID was generated as well as the prompt is associated with it. Finally, let's look at our SSE actually streaming events. And this is pretty cool because we can actually see the AI generate kind of like a ChatGPT-like experience where it streams each individual section of it so you know what it's writing out. Awesome. So now let's go ahead and wire this up into the UI where all of those API endpoints get hit. All right, so before we get started, one small change that I made off screen is I actually renamed image in story. Before, it was images in stories. This is not consistent with what is actually set up in the storybook today. So if we rename those to be more consistent, it makes it a little bit easier to follow if you're actually going to our open source repo. So with that in mind, all done there. Let's start getting our app.view ready. This is going to be the entry point for our entire front end. So when you're editing this, you'll want to focus on putting styles, markup, and components that apply to the entire application. In our case, we're actually going to be specifying the metadata for the application, as well as a special component called Nuxt page. A component is a logical piece of styling, markup, and logic that we can import into the application. And we will be writing some of those today, but for now, let's write out our app.view. So here's the code that we're going to be using. First, we define some metadata using the useHead composable from Nuxt. Then we define our wrapping container here. This is all just styling to ensure that it's centered and has gutters and appropriate spacing and things like that. Then we import the Nuxt page component like I mentioned earlier. This class is actually not necessary. And finally, you'll notice that we have this U notifications. This comes from Nuxt UI and is a way for us to hook into using Nuxt's notification framework. These styles right here are actually brought in by Tailwind CSS. So I'm not too focused on the styling component of this tutorial. So if you're curious about this, you can take a look at Tailwind CSS's docs and see what's going on here. So with that, let's go ahead and look at this in the browser and see what we're looking at. So right now it's offline. So we're going to go ahead and write yarn dev to turn it back on. Give that a second to load up. All right. And with our application booted here, we actually have nothing rendered because we have no stories, or we have no pages rather. So let's go ahead and start creating some pages. So if you remember from earlier in the API section, we had a API that was file-based, that had file-based routing. This means is essentially the file directory structure is how we build out the APIs. So that actually applies the exact same way to pages. So first, let's go ahead and make a pages directory, like so. And in there, we're going to create an index.view. The index is, like in the API, going to serve at the root. And so essentially, this is our home page. For now, we'll add in a really simple hello world. And we can view that. We can view that inside of here. And we can see hello world. If we want to add in another page like foo.view so that we can actually have a route, let's see what that looks like. Awesome. And so that's the basic of file-based routing for pages. Let's go ahead and move on to how we'll actually be rendering our stories. So let's take a look at that. First, we're going to create our stories directory. Then in here, we'll go ahead and create a route-based parameter called name, and we'll make this be a .view file, like so. All right, so now we have this empty file. Whenever I write my view, I like to import in the script first and do that. So let's start with that. First, we tell Nux to set this up, or view rather, to set this up, and we use the language TypeScript. All right, so next we're gonna import our pages type that we made earlier. If we reload this, it'll actually fix that import error. All good there. And now we have a helper type that we have, our helper function that we have yet to implement called unmangle. What unmangle is going to do is it's going to take the name of the folder stored as is, and it's going to capitalize each letter and replace the dashes with spaces. So let's implement that now inside of our library. And we're going to call this unmangle.ts. And it's actually really, really simple. This is going to look a little bit something like this, where we replace the dashes with spaces, capitalize the first bit of each letter, and then we would just return that as a default function. And we're ready to go back into here again. Our getIgnore is actually ignoring our stories directory, so we can rename this to be story as well, like that. And we're all good there. And we can reload to fix up our types and our imports. Sweet, and so we're looking good there. Next, we're actually going to be delegating routing to Nuxt as normal, and so we're going to use its composable to import the route so that we can grab that name parameter. Then we'll be rendering the name, pages, and current page of the story, starting at 1. By making this a ref, we're actually able to make sure that the page changes whenever one of these values change, so we'll be re-rendering dynamically. And you can ignore these little comments. These come from Copilot. Next up, we're going to define our onMounted, like so. What mounted means is that the application has been loaded completely and all of its children have been loaded completely. So in this case, what we're actually doing is we are onMounted, changing the pages.value, which is right here, to be the value of a get from API story and then the name of the story. So this is actually grabbing the pages of the story. And we have one last thing we want to grab, which is the code to actually change pages, the code to actually change pages will look a little bit like this. It's just going to be incrementing and decrementing the page. And with that, we're actually ready to start writing some markup. So let's get started there. One thing to keep in mind is as I go through this markup, it isn't the focus of this tutorial, so we're going to breeze through it pretty fast. All right. So first, we're going to add in our containing div. Next, we're going to add in the header of the page, like so. After that, we're going to go ahead and add the buttons that allow us to change pages. Like this. And then we can finish this off by actually adding the code that actually renders the story itself. And with that, we are finished with this page. Let's go ahead and take a look at what this looks like in the browser. So we're going to go to /story/the-adventure of Foo. And we're rendered now. We have a little issue, so let me debug that really quickly. All right, so we found the issue. So let's go back into our API here. And in the API, what we're going to do is we're going to update our get here. And we're going to update our get here. And we're going to update images to be image instead. And then that'll fix that issue. And with that, we can see our beautiful image here on the right and our text on the left. If we want to actually see a story that is able to change pages so that we can see what that looks like, we can copy these two files over, paste them, and rename them to page 2 .png, and txt respectively. Like that, and like this. So if we reload the page now, we can see that we actually have the ability to change pages. And just to prove to you that that's happening, we can rename this to be foo. Reload, and we're good to go there. Awesome. So with that complete, we can move on to actually writing out some components and finishing out the app.view as well as the index.view of our application. So first, let's create the component that will render the links to the various stories that have already been created. To do this, we'll start by creating a store. This will allow us to reference state across the entire application, but this is not entirely necessary for this tutorial, but serves as a good demonstration for those Nuxt applications that want to utilize state, which is most of them. First, we start by creating a store directory, so let's go ahead and do that. Then in that store directory, we'll create an index.view. If you recall from earlier, we're going to be using Pinia for our storage management, and doing so is actually really simple. First, we define and import the store from Pinia. So we'll do that here. And this actually needs to be a TypeScript, so let's go ahead and do that. So we import Pinia. Then we're going to want to go ahead and export our main store. So I'm just going to breeze through that pretty quickly, and we'll explain it once we have it in. So that's what this looks like. First, we give it an ID. This tells us what store we're working with, which in this case is main. Then we have two functions, or two states, which is pending stories and stories. This is just a map of ID to the prompt, if you remember correctly, and stories is just a array string of titles. We have the ability to add stories, add a story, add stories, plural, remove a story, fetch stories, and fetch pending stories. Essentially, this is just like a really nice helper for us to see what stories there are, what pending stories there are, without having to fetch every single time something happens. In this particular case for our component, we'll be rendering on mount, but let's go ahead and actually create that component. To get started, we'll need to create the components directory. So let's do that really quickly. The components directory is special in that every single component that we write in here will actually be imported across the entire application for us without us having to do anything. So that's pretty nice. First, we're going to create the stories component. So let's go ahead and create that, stories.view. As I mentioned earlier, I do like to still start with the script. So let's start there. We're going to import the store, import the unmangler that we created earlier. And we're going to go ahead and use the story that we just imported and set its value to a computed variable. Computed variables will just, similar to references, compute and change the application. On mounted, we're going to call a store action to actually fetch the stories. And finally, the last thing we need in the script is the ability to go to a story. So with that component wrapped up in the script section, we'll go ahead and add up the markup, which is pretty simple. In here, we have a little button that has the ability to go to a story with the name of the story. And if no stories have been created, it just prompts you to create something. So with that, we can actually see what this looks like inside of our app.view. Or even better, let's start in our index.view. So in here, we can just import stories like so, and look at it in the browser. Here's an issue that I'm going to be working through. Oh, and it looks like in this case, I just hadn't saved my file. So now that is all fixed, and we can actually see we have two stories here. So let's look at the adventure of Foo, and we're back to where we were. And we also have the adventure of friends on their way to Mars. Pretty cool. All right, so now we have the ability to go to stories. Let's wrap up our components by adding the ability to view pending stories and to create new ones. So first, we'll create the new component, which will be a button that opens a modal. On submit of this modal, we'll post to the endpoint that we created earlier to create a new pending story. So first off, we're going to need to create the new component. So let's go ahead and create that here. Then we're going to import everything same as before, which is our main story. We're also going to import our story request type that we created earlier, as we'll be using that. Then we'll use the store, set and open, Boolean, the page count options, and things like that. So let's go ahead and get those in. We're going to be using toasts, which are that notification framework that I mentioned earlier. And those are imported here, and you call use toast to be able to use those on this page. Now we need to implement our onSubmit function, which will handle when a user actually posts a story to our API. So let's get that in now and then talk about it. All right, so we have it created now. First, we're going to fetch the story by posting, or we're going to call fetch to post the story to the /API/story endpoint with our stringified state, which is just a story request object. Then on OK, we're going to say that the story is generating and fetch our pending stories. Otherwise, we're going to mention that the story failed, and either event, we're going to go ahead and close the modal, which we referenced up here as open. All right. Then we're just going to go ahead and add in our markup. So let's see what that looks like. This is some pretty simple stuff. It looks a little complicated, but it's not too bad. Basically, we have a button. When this button is clicked, it opens this modal. This modal has a little card for some formatting. In the header of that card, we say create a new story. And when we push on submits, we're going to go ahead and call that logic up there. Then we have a select menu for the pages, as well as a text area for the prompt. And finally, we have a button to create the story, which is our submits. In the header, we also have a button to close this modal. So let's go ahead and add this into our index.view to see what that looks like. Cool. And so we have this new story button. When we click that, we're able to do this. We can fill out a prompt with whatever, and we can create the thing. So next up, we're going to actually create the pending section of this so that we can see pending stories get created. So the pending stories component is actually our most complicated one yet. So let's take this pretty slow. It's also the most interesting one, as it's where we connect to our SSE endpoint. So first, let's start by creating pending stories, like so. Then, same as before, we're going to import our store. We're also going to import our stream event, as we'll be using that. Then we're going to use that store and use toast. Next up, we're going to create our data elements. We'll have pending stories, previous messages, and ES, which stands for event stream. So let's go ahead and add those in now. In this case, pending stories will be pending stories. Previous message will be used for error handling. Messages will be the messages that we're receiving. And then ES will be the event source that we're connecting to for SSE. Next, we'll create our add message function. This will add messages to the messages field here. For our components lifecycle section, we're going to be using onMounted, before unmount, and before mount. We're already familiar with onMounted, but before mount happens before it, sorry, let me start over. We're already familiar with onMounted, but on before mount happens before it, and on before unmount happens when the component is removed. So for our onMounted, we'll want to fetch the pending stories, like so. For our on before unmount, we'll want to close any streams that have been opened. And for our before mount, this is actually where the magic happens. First, we're going to create a new event source and point at it our API. Finally, for our before mount, this is where the magic happens. First, we create a new event source and point it at our API. Awesome, like that. Then we're going to create an event handler to handle any messages, like so. In this, we'll parse the event as a stream event and add it in its messages to the appropriate location. Then we set up logic for handling the final event. So let's get that in now. If the event was an error, we're going to grab the previous message, as that's typically the message reason for failure. So we'll add that in now. In this case, we're just truncating the prompt, and then we are citing the reason for this failure. Otherwise, our story has actually succeeded, so we'll add that in here. In either event, we're actually going to fetch the currently pending stories. Go ahead and edit this part out. I think I didn't grab the thing I needed. And we're going to grab any pending stories, and we're also going to delete it from the messages as well. So with that, we're actually ready to start implementing our markup. So let's close this off here. And we're all good there. We're going to be using a uPopover component for this, which means on hover, something will display. In this case, it will be the progress of a pending story. So let's go ahead and add that in now. Here you can see we'll go ahead and add that markup in now. So let's go ahead and add that markup up in now, like so. You can see here we're creating a popover for every single pending story. We're calling our new component up here. And when we hover on something, we'll see that it's writing the perfect story, and it'll be rendering the messages that we're getting, and it will make it so that we're always going to the bottom of the current messages. So with that, if we want to actually view this, we can add it into here, but we're actually ready to fully form our index.view. So let's go ahead and do that now. Awesome. So here, basically what's happening is we have our title. We have a subtitle saying, welcome to the storybook. Go ahead and select a story that you want to read. Then you have the ability to generate a story with our pending stories, or create a new one, which will be inside of the pending stories. And then there's a separate card that has the existing stories. So let's actually go ahead and see what that looks like. So here we are. Now we're actually able to go in here, create a story, say 3 friends on their way to the mall. We can create the story. And as we hover it, we'll actually see it generate the story. Awesome. So with that, we're actually completely done. We finished up our storybook tutorial. If you would like to stay connected, you can check us out at our Discord. We also have a documentation site at docs.gptscript.ai. And you can get connected on the repo, which is going to be github.com/gptscriptai/gptscript. All of the links will be down below. Give us a shout out if you like this tutorial, and until that next time, happy prompting.